Hello, everybody, and welcome to today's webinar presentation, Why Microservices Providers Matter Today, brought to you by ITEXT. I'd like to introduce you to our presenter, Andre. Andre is a VP of Products at ITEXT, a leading technology company active in the digital document space. ITEXT's flagship product is ITEXT 7, an open source library to create and manipulate PDF documents in Java and .NET C#. Andre has a strong development background and has been involved in product management for 9 years in various areas, including health, physiotherapy, and biosignals research. In his free time, you will find him cruising around the city on his bike. And with that, I'll hand it off to Andre.
Thank you, and welcome everyone. So yeah, well, my name is André. I'm from Portugal, but I've moved to well, today actually sunny Belgium, a couple of years ago to join ITEXT and to help them with product management. So I really only have a couple of slides, and then we'll get to the meat, I promise. So yeah, we got a very brief ITEXT introduction. So open source, Java and .NET. What is, I guess, relevant for this conversation is that we have been containerizing our products, and you can see here. Maybe let's turn on the pointer here. You can see here, for instance, that for one of our products, we've containerized it and made it available on some marketplaces, and I think that's going to be pretty relevant today. But I won't bore you further with it. So with that, let's kick things off. So a quick history lesson. Does anyone recognize that small symbol? I guess since we don't really have a chat, maybe we can use the questions section, and maybe we can play like Jeopardy, right? You can answer in the form of a question if you know where that image comes from what movie it comes from. I used to have that image as my wallpaper. Well, obviously a bigger version of it, and I would ask during interviews if they recognized it. If I was trying to hire someone for the product team here at ITEXT, I would ask them if they would recognize it. I'm not saying that it was used as a hiring criteria. I am not. Okay, so someone said Terminator. That's not it. That's not it. But I have a couple more hints on the next slide. Okay, someone got it. I won't give it away, but let's jump to the next one. So this history lesson will be short, I promise. Before the very actual and hip microservices architecture, what was there before? Well, that's correct. It was the monolithic architecture. You can see on the screen what a monolith actually is on the right-hand side. I guess it's all coming together with the, you guessed it, 2001 movie, 2001 A Space Odyssey movie references. So I'm happy to have shared that with you for now. But I mean, I'm not here just to kind of explain what a monolith is and to throw some Space Odyssey, 2001 A Space Odyssey references. You can actually see there on the bottom left-hand side another still from the movie where someone is, well, let's say, messing around with a mainframe, and there on the right-hand side here is the image I was showing on the previous slide, where basically it was like an interface for humans to deal with this supercomputer. So why this connection? Well, because if you look at the monolith and think about monolithic architectures, they aren't really very modular, right? It was just one slab of software and hardware, right? We all know, those big rooms, with a computer Oh, and actually, fun fact, do you know that the term bug comes from back then? Well, literally, bugs would get into the machines and mess with them, and would break things. So that's where bug comes from. But anyway, I digress. So with these big slabs of software and hardware, where you need to recompile everything, redeploy everything to get going, it was a really very long process for, if we're realistic, not a lot of processing power, at least not looking at today's standards. So all very procedural like, if you think about it. So by the way, mainframe or big iron, if feeling special, if you want to ask a favor from it. So mainframe, because they were literally cabinets with huge frames to support the whole thing. Okay. So monolithic, I mean, you can see it on the slide. Of course, since kind of everything was, let's say, self-contained, it was kind of easy to deploy, kind of quicker to develop for. I have an asterisk in there because, well, the programming languages were, very low level, stuff like that. Less latency. I mean, I guess so, because if everything was running together, it's not like they were accessing shared resources or resources over the network. Everything was kind of very very self-contained. I mean, and to be honest, I'm trying to paint a really pretty picture here for the monolithic architecture, not just from mainframe, times, let's say, but also, let's say, 10, 12 years ago, where you basically had a server that would do everything, right? It would handle, email, your web application, and your web application would do everything. You'd have the database in there, you'd have services to send email, to store data on the database. Everything was in there. So that's more what I mean with this monolithic architecture, not really mainframe, naturally, and of course naturally also kind of easier to debug, right? I mean, if everything is running on the same machine, maybe it's on the same process. I guess it's easy enough to have a system out, to have a print statement, just to see if you're getting there, of course, because naturally that's how everyone debugs their application, right? Well, don't. I can hear it already, so don't. Um, but I mean, think well, looking at these mainframes and then at monolithic architectures, things started to evolve, of course. Shared resources came to be. We had libraries, we had Unix pipelines, you name it, right? There was a really long way between these old-timer mainframes and the monolithic, and more recent monolithic architectures. So with that quick history lesson, we arrive at microservices. The be all and end all. Well, at least for now anyway, right? Maybe something even better will come next. I'm pretty sure there will. I guess it's the name of the game. But I'm not here to lecture you on what microservices are, but let's do a very quick recap. So to paint a very quick picture, let's say that microservices are like baby monoliths. Okay, so maybe not a monolith really, but bear with me. It's an ecosystem, right? It's self-contained, and it's very focused on doing one very specific task, right? That's the big thing. That's the big difference between a microservices architecture and the previous one, a monolithical one. So things are broken down into smaller pieces. There are no side quests here, and of course there are plenty of advantages, which I guess it makes it easier to understand why it has gained such wide adoption. I mean, because instead of having one huge monolith that does it all, You have these purposely created, I mean, laser-focused units that, because of its specificity, they are predictable in what they need and what they produce, regardless of how they do it, really. Kind of a black box that someone else created. Well, I mean, someone else. Could have been your alter ego, or someone on the other side of the company. But at the end of the day, you trust, these microservices. You trust them as kind of remote processes to handle very specific tasks. And of course, they can be shared, which is great, right? Where in a monolithic architecture, those services would only serve the purpose for the system where they were deployed. Where with microservices, you can have, I don't know, let's say you have a microservice just to send, emails with a REST endpoint. It just receives an email address, a subject, and the contents of the email. And then, of course, you can have multiple services using that microservice. So microservices, I think simple enough. I think it's kind of an industry, standard. Everyone should know at this point what a microservice is. So SaaS, I do understand it's kind of a terrible segue, but bear with me. SaaS is a big word that covers a lot of cases. I mean, like Gmail or Jira, right? I mean, think about it. They are SaaS. It's software being offered as a service. You pay for it. Whether it is through the means of advertisement or you have some kind of subscription, but you pay for these services and you get something in return. But these, let's say, high levels kind of examples like Gmail and Jira are not the cases we're talking here. I'm not looking to address these very big components, but rather how we now have access to microservices on a SaaS model. Think about it. Remote microservices that someone else has created, maintains, and charges you for it as a service. So those are the SaaS we are going to be looking into here. I mean, SaaS, of course, is yet another buzzword these days and age. And hopefully that's not what got you here to watch this presentation. But if you think about it, then there are a lot of SaaS services. There are mostly microservices operated and maintained by a different team, which is super handy, really. So someone took the effort to build this black box that does exactly what you are looking for, and all you have to do is pay for that hard work, typically per transaction or per document, document generated. So it can be very cost efficient for you as a consumer of these services. But I think what we're talking about here, we can effectively describe them as a remote microservice. So here, looking at this small image. So in here, these black monoliths with a question mark, they are then these remote services that you on your own microservice architecture are consuming. You're using the services that these black boxes provide. Well, I mean, us being ITEXT, and thank you DZone for the introduction, and being in the PDF space, and I don't worry about it. I'll just use it as kind of as an example. I won't bore you any more than that. But as being ITEXT and being in the PDF space, we do see some of these services popping up here and there. Either in the form of a template filler or to do some actions like merging, splitting, or running through an OCR process some images into PDFs. But it's not the perfect world. I mean, why would it be anyway? Although need is starting to trump some privacy concerns, not just towards SaaS, but also cloud platforms. So for instance, I was talking with a technical manager the other day for a big insurance company. And I mean, you can imagine that they are very wary of their privacy. But he was making the point that, even though privacy is, of course, number one, having the flexibility to reach out to a service, to a remote service, for instance, to OCR, the forms that the customers submit to them, um, trumps, trumps the difficulty that it is for them to be able to scale up and down those services on their own premises. So although this is, I mean, not, you can think about it not about SaaS specifically. You can use this when talking about, okay, SaaS, but also, cloud providers, like AWS or, Google Cloud or Azure, etc., etc. But there's this very big, huge concern about sending very sensitive data to a third party. After all, you're in essence sending it to a black box. You don't know, what happens with your data inside of that box. You don't know if your information is, relayed elsewhere. If what kind of transformation happens in there. So of course, I mean, other than sharing your precious data with a black box on an undisclosed location, you're also sharing something else. You're sharing resources, right? So you're sharing, processing power, you're sharing memory, network, etc. I mean, some things are worth sharing, although others are not. Am I right? So the big issue here, besides, being protective of your own information, another issue arises, which is predictability, right? Things need to be predictable. But if things are shared, you don't really know which piece of the pie you are getting. Even if the things are absolutely compartmented from a hardware perspective on the other end, there's still network and so many other things that need to be shared, right? I mean, you can have all of the guarantees in the world that you have, your own instance being spun up every time you need it and whatnot. I mean, but there are also always resources that are shared, even if it's just network, for instance. So microservices, good. Software as a service, okay-ish, I guess. Pretty convenient, but it has some, some caveats. But how can we then leverage on the work that someone else has done? It's like we're in a world where libraries do not exist. Maven repos, Nugget, or GitHub does not exist, right? It's not like you can go into GitHub and see the source code of the SaaS service that you are using. It's not like you can see exactly what's happening inside of those SaaS. So there has to be a better way to translate these shared resources concepts into microservices and still feel pretty good about it, which I guess is why we're here today. So enter microservices as a service. I guess. I guess. So what have we learned so far? Well, 2001: A Space Odyssey was clearly ahead of its time, and FYI, it is a movie from 1968. That's right, 1968, 68. That's mental. Well, basically, what we've learned so far is that although microservices, they are the hippest architecture here, where the pros outweigh the cons, and that there are some SaaS that they act pretty much as a remote microservice, except that they are built and maintained by someone else. But who cares, right? I mean, again, it can be someone on the other side of the company. You don't have to know them. Things just need to be clearly defined. And since it's business oriented, very specific, then you're good to go. But there are some considerations that need to be taken into account, as with everything in life. And let me tell you, we definitely have trust issues. So we have a container, and if we add to it a REST API, what do we have? A microservice, right? That's typically how microservices are consumed this day and age. I mean, sure, there are other ways, but I guess this is the most popular sexier way of doing it. The thing is, there are some solutions that offer SaaS-like functionality, but inside a container you can somewhat control. It feels like the best of both worlds, really. You can get the convenience of having a microservice with the insurance, but well, if we're honest, the responsibility as well to deploy it and secure it on your own environment. So you have these providers that distribute containers that you can manage or orchestrate with something like Kubernetes. Looks like I hit one more tech bingo. Sorry about that, everyone. Sorry. Well, as I was saying, there are multiple ways already where microservices are being distributed. There's Docker Hub, right, where you can pretty much download a container. A lot of them just have a very well-defined REST API. So then you can just deploy it wherever you want to deploy it. You can control the whole environment. And of course, there's AWS Marketplace and etc. There are a lot of places now where you basically can download, can subscribe, what have you, a microservice. So I guess what I'm saying here is that these projects becoming microservices, or I mean, let's say remote libraries, are really starting to pop up here and there. And it looks to me like a great compromise between control and flexibility, as you are in control of its deployment environment. Of course, I'm not here to say that these services are, again, the be all and end all, but I do think it is an interesting bridge stopgap solution to address some of the privacy concerns or dependability on a third party. Or fourth, if you also consider the underlying infrastructure provider while enabling you with a great deal of control. So what that means is that since you can pull and you can literally pull from Docker Hub, and using command line tools, you can pull a specific version. You can get that very optimized functionality maintained by a vendor, and then deploy it on your own infrastructure, right? It doesn't matter if it is on premise, if it's on Azure, AWS, Google Cloud. I'm always referring them three, just so we can be friends with all of them. So then they are scalable. You can scale them yourself, quicker to deploy. It's typically there's just like this recipe for you to spin up a new instance. And of course, that allows you to focus on a bigger picture and not kind of worry about these small components. And then updates are, I don't want to say literally pushed to you, but I did want to make a reference about the pull command that you can use in Docker. The cons, of course, I mean, it's still a gray box. You don't really know what happens inside of that container. Well, I guess you know a little bit, right? But there's always, I mean, potentially going to be, a binary in there somewhere doing some stuff. Where, I mean, I guess if it's an open source project, then I mean, sure, you can see it. If not, I mean, not as much, but still, you do know what comes in and out of that gray box. You do have control over that. It's not like that gray box is going to, reach out to a server on the moon, without your control. But of course, yeah, as I was just saying, it's still a gray box. The responsibility is yours, to maintain it, scale it, deploy it, making sure that everything is working correctly. So, I mean, I've mentioned this multiple times. Are these microservices kind of a remote library? I I I guess so. I guess so. I mean, think about it. As I was just saying before, you control its environment. You know exactly where it's deployed. You know exactly, what ports it has open. You know exactly to what other services or other servers you are talking with. So you have full control over that. You can version control it like a library. So you have all of these versions tied with these microservices that you pull from Docker, that you deploy on AWS, ECS, or EKS. So you can control the version. You can kind of track the change log, see if it makes sense, go to the next version or not. It's under your control. It doesn't kind of spin out of control without you having a say in it. And of course, yeah, like a library, you can just integrate it into your system, speeds up your development, etc. So this is kind of what I wanted you to kind of consider, kind of as a summary here for these slides. We started off, uh, with a monolithic architecture where everything was done on the same server, on the same machine. Sometimes, okay, set of machines with a load balancer in front of it, but then the machines were basically replicas of each other. Then we moved to microservices, where things were a bit more distributed and focused on very specific tasks. Then we had SaaS, software as a service, which I think, but it's of course it's an opinion. It can be seen a lot of cases as a remote microservice. So it's something remote that does something very specific for you. But then, of course, the perils of SaaS, or the dangers, because it's out of your control. Where it's deployed, how it's deployed, what's happening inside of those remote services. And then finally, we already have a lot of companies, a lot of efforts, and I mean, naturally, ITEXT isn't excluded, where these microservices are offered to their users, to their customers, so that they have the convenience of a microservice. with the good bits of SaaS, of software as a service. And that's what I have for you today. I think we have time for some questions still. Okay, I think yeah, I already have some questions coming in. I'll try to keep up. So aren't microservices as services still a black box? Yeah, so I think, and just putting this one to kind of make a point. I I I think it's not really a black box. It's a bit more of a gray box. You can still see inside of the container. You can see everything. You can see the processes running in there. You can see what's coming in and coming out of that service. So I would say that they are you do have more control. They are a bit more transparent than black boxes. Absolutely. So microservice, hope not a mandate to be containerized. No, no, indeed. I mean, you don't have to use containers in a microservice architecture. No, absolutely not. Um, of course, I mean, it can just be one machine talking with the other, and the other machine, it's not containerized. It's just, a regular heavy operating system doing all kinds of stuff, plus um, um, plus making available a microservice. So yeah, I would say definitely not a mandate to containerize. No, just an example I wanted to give here. Would there be a finer grained way to track changes between new services? Well, I think so. I mean, if we consider, for instance, again coming back to containers, just because it is the examples I was using here. If we consider, a Docker container, and I think that's kind of the industry standard these days. You typically do have access to the Docker file where you can see, or you can actually build the container yourself. And that's something that we enable at ITEXT with Ditto, for instance. You can look at the Docker file, so you can see, the operating system version, you can see the JDK version, you can see, the web application version, if it's no, yeah, if it's a Wildfly, I was thinking about Tomcat, but if it is Wildfly or something else, so that there is some sort of information that you have in there that can help you to track changes on those services, on top of course of whatever change log that service provider shares you with. Another question, just having a sip of water. Okay. Biggest challenges of microservices: monitoring or making them stateful? Yeah, I think it's a good question. I do think that microservices, well, unless your database is a microservice, I do think that microservices typically are stateless, because I mean you want to have the capability with microservices architecture to bring up and down microservices at will. because of course that's one of the powers, right? If there's something wrong with a particular instance of that microservice, and you want to bring it down and bring another one up, just to to make sure that you have availability, then I mean you shouldn't really maintain any state on those services, right? I mean, of course, you can always have somewhere to persist some data that can be relevant for those microservices to consume, right? Whether it is some shared space on file system, or if it's a database, like NoSQL or an RDBMS system, etc. But and of course monitoring is paramount, of course, because yeah, you need to know if they are down or not. So you mentioned that you have one product using this strategy. Why not go all in? Yeah, so yeah, I think yeah, of course, good question. So I'll go back maybe to the initial slide. Just bear with me here. Okay, there. So I mean, indeed, with the detail here, which is a template-based document generation tool that we have indeed containerized it and make it available in multiple ways. So we have a Java SDK. We've containerized that SDK and made it available on Docker Hub. And now we've even made it available on AWS Marketplace. So I mean, at the end of the day, it's about offering multiple choices for the users of these tools, so that they can deploy in however they feel is more convenient. But indeed, to be very honest, and I guess that's why you meant about going all in with our suite, where of course we have ITEXT 7, our open source core product, which is I think why ITEXT is most well known for. We have started also some efforts there. So if you go to AWS Marketplace, you can subscribe to the 7 suite as a service. So then you can deploy on your private space, either using ECS or EKS. But we haven't yet, and that's the to answer the go all in, we haven't yet made it available like on Docker Hub and stuff like that, to make it easier and more convenient to to deploy it elsewhere, and however you prefer. So another question comes in. So this still assumes some level of trust on services providers. What can be done about that? Yeah, so indeed, I think it's tied again with a gray box. I mean, I think at the end of the day, I mean, if you're using a library from a vendor, I think it's kind of the same. If you're using a closed source library from a vendor, I mean, you don't really know what's happening in there inside of it. Although you control its environment, right? I mean, you know if or you can know if it's making calls to the outside of your environment, if you're using a DLL or a jar file, whatever your poison is. And with microservices it's the same thing, right? I mean, you're basically getting a recipe for you to basically deploy locally a library that has been containerized. So I think the level of trust for those scenarios, I would say it's the same level of trust as you put in a normal library, a jar or a DLL. I would say. What I would argue is that it's one level up in terms of trustiness in comparison, for instance, with a SaaS, where you have no control really over the deployment of these services. Hopefully that answered that question. So I think we're kind of running out of time. So that's it from me. Thank you all. And I mean, feel free to reach out to me over, I don't know, social media or what have you. And back to you, DZone. Thank you.
All right, well, DZone would like to thank Andre for a great presentation. And DZone would also like to thank ITEXT for providing the audience with a great webinar. And lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career.